Excavation is one of the hazardous operations in construction work. Here, we will talk about two types of accidents in excavation. The first one is a utility strike. Every 84 seconds every year, an underground utility is hit on in the United States. This has resulted in thousands of injuries and hundreds of deaths over the past 2 decades. In addition, utility damage costs are very high at around $30 billion per year. Another commonly occurring accident is struck-by accidents, which account for 34% of total cases of injuries. A typical case is when equipment gets into the operator's blind spot and the operator cannot see this equipment. These accidents have also resulted in thousands of fatalities over the past few years. So, let us think about the root causes of these accidents. According to the statistics published by Common Ground Alliance, 32% of utility strikes are caused by the insufficient locating practice. Another root cause is that some operators lack situational awareness. Sometimes they are unaware of on-site dynamics and unable to predict potential hazards nearby. So how do we solve these problems? Here are our thoughts on how to reduce accidents. The first one is to develop an automatic pipe locating system that detects buried utilities in the excavation process. The second one is to help operators become aware of site dynamics. And the third one is to develop a visualization system that can monitor the surroundings and provide proximity warnings in real time. We are now developing a smart excavation system, a unified solution integrating all the functionalities. We aim to create a digital twin of real-world excavator and underground pipes. Here is an illustration of our system. We use sensors to measure the excavator's positions and poses and synchronize the excavator's movements in a virtual environment. Also, we developed a module that automatically interprets ground-penetrating LiDAR data to estimate pipe locations and reconstruct virtual pipes in Unity 3D. Finally, we developed a visualization system by combining the virtual excavator and the pipes. The system can provide users with a construction site from different perspectives, such as bird's eye view and a side view. It can also prevent pipe collisions and struck-by accidents by providing proximity warnings to operators. Next, we will show you a demo video of our visualization system. Our visualization system provides users with proximity warning for potential hazards. As you can see, when the dump truck approaches the excavator, a warning message flashes in the center of the screen. The cabin view in the middle is augmented with white mesh to delineate the complex shape of the current terrain. A target cut model was also added to the cabin view to guide the operator's excavation. When the bucket reaches the target model, the color of the model changes to red. The user can compare the terrain to the target cut for higher productivity. Proximity warnings are also provided when the bucket is close to pipes to avoid pipe collision. You can see the distance between the bucket and the individual pipes being calculated in real time. Also, if the distance is less than 2 meters, the pipe color changes to alert the operator. Here, you can see the buried pipe being exposed to the air and an excavator working around the pipe. The next demo video shows the progress of data streaming between the physical and virtual worlds. We use phone sensors to test our network communication pipeline. In the video, you can see data flow and the virtual object moving in synchronization with the phone. This mechanism will be applied to the excavator's real-time monitoring and movement reconstruction as our next step.